And they need to know this more than the consumers. People buying equipment are curious, but people who make the recordings are professionals. It's their job. So it's particularly important for the engineering community to have this information. Because what I will tell them, they don't know.
This panel is being recorded, so we probably make it available for anybody interested and distribute it as well.
Good. Just to say, there are two worlds in audio. There's the consumer world and the professional world, right? So the consumer world is people buying audio equipment almost like a hobby, you know, buying equipment and changing it and, you know, interested in equipment, like more or less like a hobby. And then there are professionals who make recordings, and their interest is different. They use audio as tools to make recordings. It's their job. So it's really, there's two different, you know, there's two different worlds, and they're both good, but they're different. And I am both. I work in consumer audio, but I'm in the beginning a recording and mastering engineer. I understand the world of pro audio. So I'm happy to talk with both, but in particular, I'm happy to communicate with the pro audio community.
We'll make sure that they get this recording of the panel. We're ready. Can we start?
Sure, no problem.
Mr. Levinson, for me it's a personal honor to be able to talk to you, because you don't know that, but I've been following you for half a century now. And
thank you.
I could say I think the same for almost everybody in this room. For me, you are a man on a mission. And would you agree that from day one of the digital audio, some of the, you know, so to speak, right-wing audiophiles and the audio community were quite skeptical. They were complaining something's not quite right. And after all these years, it's you who decided to make things upside down a bit, not to check the cables, the links, the semiconductors, the players, the speakers, but the human brain. Am I right that that was the missing link? Could you elaborate on that?
Sure. Well, first, when digital audio first came out, a lot of recording and mastering engineers were not happy either. A lot of them got headaches. They could only work a short time before they got tired. They used to work for 10, 12 hours with pure analog, but when digital came, they got exhausted after a few hours. So it's not just the audiophiles. The first people not to be happy were the engineers, but they didn't have much of a choice. However, the same feeling was with the audio professionals as you know, as with audiophiles. Actually, just to clarify, my work with Daniel Hertz includes semiconductors, software, electronic architecture, and speakers. Basically, Daniel Hertz is a technology company dedicated to, let's say, creating the new audio technology across the board. So digital is part of it, but it's not the only part of it. The entire audio industry is running on technology from 1960s, 1970s, because that's all you can buy. The transistors, the chips, the power supplies, the drivers, they're all very old. And my company is dedicated to creating the new technology. But nothing is as important as the digital audio problem. That's the fundamental problem. But I've been working on that for 30 years. It's not something new. It's a long work.
If I could interrupt for a second, do you remember the times in the 80s after all the digital things started that people were kind of, nobody dared to question the crystal sound of CD, for example. It was new, it was revolutionary, it was, if you criticize that and say vinyl's better, you were an old boomer.
Well, first of all, there are two sides to this. There's subjective and there's objective. Objective means I think this, you think that. I like this, you like that. There's another world which is called objective. For example, a frequency response test. If an amplifier is 2 dB down at 10 kilohertz, it's not an opinion. It's a fact. It's a measurement. Okay. It's consistent, repeatable, and documented. Whenever you have measurements, you have something objective. And there have never been any objective measurements of digital, because with conventional audio tests, it measures no problem for frequency response, noise, distortion, the usual stuff, because the problem is not the digital audio, it's the way the brain responds to it, and nobody ever looked at that. So we're the only company that has a measurement as valid as frequency response, consistent, repeatable, and documented, that identifies the presence of PCM processing and what the problem is, and we have a solution as well as a patent from the U.S. Patent Office on it. So it's a big work.
And the solution is called the C-Wave?
Yes, well, let's talk about what the problem is. Ask the people there, does anybody know what is the difference between pure analog and PCM digital audio? Ask the people what they think. Anybody would like to answer that question?
We actually had a panel, we just finished, more or less about this. It was analog versus PCM versus DSD.
Well, I wasn't there. I don't know what they decided. But in the interest of saving time, I can tell you what the difference is, and I can tell you how to measure it. And I can tell you how to fix it. Pure analog is based on a continuous waveform. Pure DSD is based on a continuous waveform. PCM is based on a non-continuous waveform. The brain reacts to pure analog audio with no stress response to the format, and the same for pure DSD. But PCM digital audio is a non-continuous waveform, and the brain has a stress response which can be measured in a number of ways. But one of them we're using is a $14,000 health diagnostic system, and it enables us to identify the presence of PCM processing. You might be interested to know that in 2001, I reported the SACD that Sony used to introduce DSD to the world, called Live Recordings at Red Rose Music. And that recording was a combination of different tracks I put together over a year. Microphone signals direct to DSD. No mixing, no mastering, no EQ, no processing, just mics to DSD. That was pure DSD. And people responded very positively to that. My personal interest in DSD was exactly because it felt like pure analog and it tested like pure analog. Then, when Sony started making SACDs, I got a few of them and they sounded like CDs and they tested like CDs. David Kawakami was the head of DSD for Sony, and he was based in New York at that time. So I called him and said, hey, David, these SACDs you're producing are actually CDs. Oh, no, he said, they're SACDs. I said, well, they don't sound like SACDs and they don't test like SACDs. He said, what kind of a test are you using? I said, well, why don't you send me 35 SACDs and I'll tell you which of them are PCM processed and which are not. So I was on Madison Avenue, Sony was on Madison Avenue. He sent a courier with a box of recordings to me, and I tested them in 15, 20 minutes and sent him the results. A few hours later, he called me back. He said, I checked the mastering reports for them, and you were 100% right. 33 were PCM processed, and 2 were not. One of them is yours, and one of them is a Turtle Records release. Sony confirms that your test is valid. And they told the Audio Engineering Society in New York the same thing, that our test is valid on a totally blind test. We identify PCM processing every time, and we've done it ever since. And that can be done in different ways, but the nice thing about the health diagnostic equipment is that it produces printouts. It's based on Windows software, Windows-based software, so it's repeatable, consistent, and documented, and you can see the results. And what C-Wave is an algorithm that essentially fills in the spaces between the samples with original musical information so that the brain responds like to pure analog. It doesn't feel that it's a non-continuous waveform anymore. That's, if you have a PCM digital audio recording in any format, MP3, CD resolution, 24:192, whatever resolution, they will all produce a stress response in the brain, except if they're C-wave processed, and then they test like pure analog or DSD. So it actually does work. On the other side, on the subjective side, of course, that's really important. What do people think? How do people feel? And so far, the subjective response has been very good too. We ask people whether C-wave processed PCM sounds like digital audio, and they all say no. There's no digital sound, no digital feeling. Everybody feels the same way. So it seems to work on the subjective side, and it works on the objective side. So far, so good.
Would you elaborate on how the C-wave thing works? Because it fills in the empty spaces?
Okay, let me put it this way. Imagine an oscilloscope screen. You're looking at a scope, and you look at an analog generated waveform. Okay, so it's smooth. Now look at a digitally generated waveform, and you see sample space, sample space, sample space, okay? Now with C-Wave is a very subtle, finely tuned reverb algorithm that looks like leaves of grass. If you look at a scope, reverb looks like, leaves of grass. Okay, but it's continuous. And let me put it another way. PCM manipulates the sound. It tries to convince you that it's a continuous waveform, right? But the brain is too smart. The brain knows it's not, but, so C-Wave restores the waveform so that the brain feels it's continuous, and it's fine. But it's that finely tuned, it's a big job to get it right. So that finely tuned algorithm looks like leaves of grass. You can see it on a scope. It's easy. You can you see, and the ear follows that and doesn't have that stress response because it's putting back what got taken away. I mean, if you have a space, something's missing, right? So C-Wave is sort of putting it back in. Does that make sense to you?
It makes absolute sense, and for me it's even surreal because I'm not that much technical, but from day one of digital audio, I was wondering, is it a mass illusion? Because in digital, we simply don't have all the information. They're like empty holes. And also, because of that, there is no interaction between the two samples, which would be in an analog domain. And so how come people took...
You're thinking.
Half a century.
Everybody's thinking about what the thing is. These are thoughts. You're thinking about it, and that's okay. But what is really happening is a little bit more difficult to understand, because it's hard to know if it's what we hear or is it the stress response. The stress response is instantaneous. It occurs instantly, less than a fraction of a second. It's instant. And the stress response changes the way our brain works. So the question is, are we hearing, is it that the sound is different, or is our brain working differently? So that requires a little study. But it doesn't matter, because C-wave fixes the sound and it fixes the stress at the same time. So that's the thing. The sonic difference is very subtle. You can hear it. I mean, a lot of people it's not a sound effect. Let me give you an example. Let's say you have a 30 inches per second pure analog master tape, and you make a digital copy. You want the copy to sound like the analog tape, right? But it doesn't. Why not? Why not? Well, if you make, let's say, a WAV file, copy of the analog tape, and with C-wave processing, it does sound like the analog tape. That's cool. Well, what is it? Is it restoring the sound, or is it because the stress is gone and your brain feels it's pure analog? It's hard to say. That requires some more study. But the idea is to make digital audio transparent as a medium, right? So that C-wave is intended to make digital audio more transparent, so it doesn't have any coloration. It doesn't create any problems. And obviously, frequency response is okay, noise is okay, distortion is okay. So if the stress response is eliminated, well, not so bad. It actually works, as far as I can hear. And we've been shipping product for a year and a half to people. The Maria 350 amplifier is the only amplifier in the world so far that has C-wave built in, embedded. So all signals are processed on the fly. That's another innovation, by the way, is the Mighty Cat chip. C-wave itself is an algorithm. How do you give it to people? There's only three ways. It can be ported to a device, let's say like a mobile phone. It can be in software, or it can be embedded in a semiconductor. And Mighty Cat is a semiconductor that has the internal architecture to run C-wave. So when you have a Maria 350 amplifier, all sources are processed on the fly automatically. That's a very cool thing. And the Mighty Cat chip is also a highly innovative design that, in my opinion, sounds more like live music than any solid state or vacuum tube technology I've ever heard. It's a single chip, 25 millimeters long, that replaces the DAC, the preamp, the power amp, and all the interconnect cables. So it's more compact, lightweight, low heat, less expensive, fully programmable, and has a lot of advantages in addition to running C-wave. That's a very cool semiconductor. I don't know if you know this, but it takes many years and many, many millions of dollars to develop a semiconductor. It's a huge work. We had to partner with a U.S. semiconductor company to get that done. That's a big deal. Anyway, if you want to hear what C-Wave is, just listen to the sound of the system there and see if you hear any digital sound. Let me know. I would be interested in your, in any comments or questions from anyone. What was I going to say? Wait a minute. So the most important thing is, how do people feel about it? Do people like it or not? Of course, we're very interested in what people have to say and happy to answer any questions. I'm not really interested in building a big audio company. Just want to make a very small boutique company to prove the brand, prove the technology, make people happy. And, the real financial future of my company is in licensing technology to big companies. But our boutique line is there so people can actually, hear something and, and we're very interested to know what people think and how they feel.
We'll get to questions from the floor in a second, but I'd like to ask you a personal question. Sure. Were you surprised with the results? I mean, the stress measurements.
Say that again, please.
Were you surprised with the results of the stress tests?
Well, did you read the history of C-Wave paper that I wrote?
Yep.
Because the person who first discovered the physiological nature of digital audio problem was a doctor in New York. In 1977 or 8, he had one of my preamps, my first preamplifiers, and he said, "Mark, I have a problem. Can you come over?" So I went over, and he said, I've been using this LP in my therapy. He was a medical doctor, psychiatrist, and therapist who used music in his therapy. Very advanced, incredible guy. And he said, "I've been using this LP for years with positive results, but it's getting worn out, so I bought a new copy. And I get reverse results. It hurts people. I don't understand what's going on." So we looked at the new copy and the old copy, and the only difference we saw was the new one said digitally mastered. And he found the same problem later when the CD came out and the digital recorders came out, everything had the same problem. So he was the first one to identify the PCM digital audio problem. He went to an Audio Engineering Society convention back then when the CD was announced, and he tried to tell Sony what he had found as a doctor. And they threw pencils at him, like totally disrespectful, no respect at all. And he said they didn't want to know. They did not want to know there was a problem. So I asked him if he would help me find the problem. And he said, yes, on one condition. If you can't fix the problem, you promise to get out of audio. Because he said, if you're the kind of person who would make money selling products to people that make them sick, and you know it, then I don't want to help you. You're not the kind of person I want to help. And I said, okay, I promise. But it took me a lot longer than I expected. But I wasn't exactly surprised because Dr. Diamond was using applied kinesiology to identify PCM processing, which is not documented. It's not something you would call scientific proof, but it does work, and it is consistent, and it is repeatable. So I knew there was a physiological phenomenon, but we just didn't know how to document it in a scientific way. But when we tried avatar testing and it worked, it just confirmed what we had already discovered with applied kinesiology.
Well, that's surreal. It took the mankind half a century to realize that. Thank you, Mark Levinson, for saving us.
Well, let me just say, I don't want to take credit for this myself. Dr. Diamond was the one who first identified it. The person who really came up with the solution is my mentor, Dick Berwin, who's now 98 years old and still alive and still working, still listening to music and still kicking my ass from time to time. He had the genius idea of what was wrong and how to fix it. So, this is, again, most real innovation is a group effort. For example, what is electricity? What is when you plug something into the wall, what is it? Well, Nikola Tesla combined the work of 3 people, right? Volt proposed how to measure voltage. Hertz proposed a way to measure frequencies, and Ampere proposed a way to measure current. So volt, for example, 220 volts, 50 hertz, 10 amperes. That's the work of Volt, Hertz, and Ampere, but put together by Tesla. So it's a group effort. So what I'm doing here is just really a group effort, of people who love music and love audio and want to make things better.
Mr. Levinson, we so much appreciate explaining to us in simple words what it's all about. And for us, it seems like a new audio revolution. It's not all over the papers, all over the internet, but it is a revolution. I think that nothing ever will be the same again.
Well, Poland is a country that has developed many innovations. A lot of Western countries don't realize this, but Poland has been a country that produced many astonishing innovations. So I'm really happy that you guys appreciate this. Especially you have a culture that does appreciate innovation and has produced a lot of it. So, I really appreciate the opportunity to talk with you, and I'll be happy to answer any questions.
There is an agreement, internal agreement here that you'll get about 50 or 60 questions on mail over the weekend. Okay?
I would prefer to talk to people so that everybody hears it. I don't really have the time to answer 60 questions. I'm just too, you can't imagine what I have to do. If people could ask, you're welcome to write it, but sometimes the answers are complex. And that means a real answer can be quite long. And I don't want to give people an incomplete answer, but I'm not sure what the questions are. Could people just ask, let's say, 5 or 10 questions right now so everybody can participate in the discussion?
With your permission,
it's important that everybody is in the discussion.
With your permission, could we ask for another Zoom call when they prepare everything?
Sure, but they can just ask right now. Just ask him. Hey,
okay.
Ask him something.
One question from the floor. Bardzo proszę.
Czy uwolni technologię C-Wave dla innych? Będzie dostępna.
The question is about the C-Wave technology. How it's going to be available for others?
Well, this depends on the industry. If companies buy the chip, they can use the chip in a product. If it's a big company that can port it to a device, that's the easy way. It could be available as a VST plugin for recording companies that want to process a recording. It depends how the industry reacts to it. The first step is for people to understand how important it is And most companies don't want to accept it because it's disruptive. It changes everything. And you know the old saying, people want to make things better, but they don't want anything to change. And there's a lot of politics involved. Sometimes companies feel threatened. And how can you make things better if you don't change something? So if there's a company that's interested, they're welcome to contact me. We'll see what they want to do. What we really need is to partner with a semiconductor company that will produce a line of C-Wave enabled chips and make them available to the world. Like, let's say, Texas Instruments or Analog Devices or, I don't know, some chip company. But they don't care at the moment. So they probably wouldn't do anything right now. But if semiconductors were available to the world, it would be easy. Just buy a chip and do what you want, right? You can do anything you want with it. But that's not available at the moment. Porting C-Wave into a device is more complex, and most audio devices don't have that capability. But if somebody has a specific interest, they're welcome to contact me. We can see what we can do. I mean, the purpose of this is to make it available to everyone. But I can't do that myself. You know, we need cooperation and collaborations with companies in the industry.
Okay, last question from the floor. They need time to prepare questions. We kindly ask for another Zoom at the right time for you.
Sure, no problem. Okay. Just to say,